Good morning. Today in this class we will start first PU syllabus officially by taking the supposed to be third chapter. First part is physical world, which is not that important in the perspective of examination, and second chapter is actually it's about units and dimensions. We think it is always better to discuss about units and dimensions when all the chapters of first PU are understood and met with, because it involves several aspects that you don't know. Better we will acquainted with physical concepts. You don't know what is viscosity, for example, and there comes out to be the unit of viscosity. Before knowing what is viscosity, if I say this is the unit of viscosity, you cannot understand. Length is measured. Length unit is meters. It is very simple because you already know about length, but you don't know about viscosity, right? So if I say something as the unit of viscosity, you may not get the clear idea. That's why we will put it at the last of syllabus completion. We will start with motion in a straight line, which is directly linked to your high school. Okay, so we will start with motion in a straight line with the previous knowledge, Okay. Good morning. My name is G.B. Swami. I take physics from you for this chapter, and motion in a straight line is what I will start with. Okay. The reason I have already explained. This is for your betterment, your convenience only, not for my convenience. Okay. First PU, motion in a straight line. Motion in a straight line means it's about one-dimensional motion. One-dimensional motion means moving in a particular axis, not without any deviations. Suppose a car is moving on a straight road. We can say that it is moving in a straight line. If you throw a ball vertically upwards, okay, not like this. If you throw somewhere and it will fall somewhere, not like that. You should throw it in such a way that it comes back to you in the same position. Vertically upwards and vertically downwards. So this is also motion in a straight line. And whatever moves in a certain direction without any deviation, we can say it is the motion in a straight line. It is also known as motion in one dimension. What do you mean by dimension? Dimension means a size. Size and shape belongs to. What is the dimension means? What is the dimension of this room? Means what? How much length it has, how much breadth it has, how much height it has. That's called dimension. Here in physics, we say dimension means direction. We live in three-dimensional world, we say, because we live in x-axis, y-axis, z-axis. We can move in any axis. We can go straight like this. You can come like this, perpendicular to this. And you can move upwards also. You have three axes, x, y, and z, right? And if there is an ant, if an ant is moving on the board, it is not flying off the board. It is not flying off the board. It is moving only on the surface of the board. Then we can say ant is moving in two dimensions, because if you make this ant stop here, and how much distance it has covered? It has covered a certain distance in the x-axis. It has covered a certain distance in the y-axis. It does not have covered any distance in the z-axis, because in the z-axis it does not move. It is not having any motion in the z-axis. That's why we say its motion is explained by the distances traveled in x-axis and y-axis only. It has having two directions. We say it is a two-dimensional motion. If the same ant is moving only in x-axis, it is not showing any movement in the y-axis. It is not showing any movement in the z-axis. It is showing movement only in the x-axis. That's why it is one-dimensional. Now it is two-dimensional. Now the ant has wings. Suppose ant has wings. It is not an ant actually, it is a bee, honey bee. Then it will start flying. When it flies, it will have a z-axis movement also. Now we can say a flying bee has three-dimensional motion. When we are walking on a plane surface, see, I am walking on the floor which is flat. I am moving in two dimensions. My motion is two-dimensional. If I jump, then there will be another dimensional aspect for me, because I have another, instead of this motion and instead of this motion, this is the room, right? This is the floor of a room. A person is standing there. He can move only along this direction, because his motion is characterized by two axes. Now if he jumps also upper side, then he has a motion along that particular aspect. He has a displacement in z axis. He is now in 3 dimensions. Generally we don't move in 3 dimensions. Okay. This is called motion in a straight line. Okay, fine. Before understanding motion in a straight line, we will go with what do you mean by position, what do you mean by displacement, what do you mean by velocity, what do you mean by uniform velocity, what do you mean by average velocity, what do you mean by instantaneous velocity, what do you mean by acceleration, and what do you mean by retardation, what do you mean by uniform acceleration, what do you mean by variable acceleration, what are the equations of motion. So all these things will come. I think you have already known about this in your first few classes, but let me revisit again. We will start with the number line, real number line, called as real number line. This is the origin of that line, which is represented by O. To its right side, there are numbers 1, 2, 3, 4, 5, 6, and etc. Here also, at the left side, there are numbers -1, -2, -3, -4, -5, -6, etc. Okay. You can move in any way. Suppose the particle, there is a particle. What do you mean by this particle? Why not car or bike or something else? Why do you say particle? What do you mean by a particle? Let me clear this. See, if you take a car may be having this much bigger size, okay? Its size itself is 2 meters. If a car moves to 3 meters, okay? Car moves to 3 meters. It doesn't mean that car moved to 3 meters. Car has made only 1 meter displacement. You see, car was at 2. Now car comes at 3 means its bumper has come to 3. Not that car has made 3 meters move. If car has to make 3 meters displacement, then car's bumper should go from 2 to 5. Then it makes 3 meters displacement. Okay? So that is why we don't go to that particular journey. We say that there is a particle. We will reduce the car to a point-sized particle. But it has got mass. We will not make its. Let me revisit what we have discussed yesterday. There was a number line called O. From to the right side of O there was numbers 1, 2, 3, 4, 5 and 6. At the left side of O there were -1, -2, -3, -4, -5 and -6 were the recordings, and this is the number O means 0, the origin of the number line. And we will consider a particle here, not the car, not the bike or not a person. We will consider the particle here. Why we choose particle? Because particle has a size. Particle always has a size. It has got mass also. Suppose if you consider earth as a particle, sun as a particle, what is the distance between earth and sun? How do you measure the distance between earth and sun? This is earth, this is sun. Is it the distance between their surfaces? Is it the distance between their peripheral end to the peripheral end? Or is it the distance between the peripheral end of the earth and the front end of the sun? There will be confusions. To know the exact distance between the sun and earth, we always choose the distance between their centers. It is x. This is supposed to be the center, and the distance between the centers of those two bodies, we call it the distance between them. By doing this, what we were doing is, we were considering earth the position of earth, the whole mass of the earth is concentrated upon its center. We consider sun, the whole mass of the sun, the whole existence of the sun is situated at its center. We think that this distance x is the distance between two particles, means point sized objects. We will neglect the dimensions of it, we will neglect the shapes and sizes of it, and we will just think that, we assume that the whole earth is concentrated to a point for theoretical purpose. Otherwise, if earth and sun both touch each other, what do you say? They are in contact, they are in coincided. No, they are not coincided. Even though sun and earth are in contact with each other, we cannot say both are coincided, because there is still the radius of earth and the radius of sun avoiding the coinciding of their centers. Their centers are still RE plus RS apart. The total distance between them is radius of earth and radius of sun. It is not equal to 0. Remember, to make earth and sun merge and collapse to one particular point, then we must think that earth is coincided with the sun, so that both their centers are having the same position. Okay, this is the notion of a point and particle. That's why particle concept is very important. So in this chapter and the next coming chapters in the whole physics, mechanics, we will always say particle and a particle and a particle, because the concept of particle is so much centered to the mechanics. It avoids it will make our calculations, our predictions simple. Okay, that's why we will assume that there is a particle here, means there is something here. It may be a big ship, it may be an aeroplane, it may be a car, it may be a bike, it may be a person. Let us know its mass only. It has got mass, but it has no size. That is the characteristics of a particle. Okay, so such a particle we are going to consider in a position 4. Suppose in a position 4. In the previous class, I think I have discussed what do you mean by position of a particle. First, what do you mean by position of a particle? What do you mean by position? A particular point in space, a particular point in space at a certain distance, from the origin, this is called point. This is called particle, position. This is called position. Then what is particle? Okay, I should have to explain particle first. What is particle? It is an object. It is an object of 0 dimension. It is an object of 0 dimension with mass. It has mass, but it has no size. That is called a particle. Okay, position means it is a particular point in space. In the space, it is a particular point which is measured at a particular distance from the origin of the coordinate system. Here, that particular measurement is supposed to be 4 meters here. Okay, this is called position of a particle. Next, we will go to displacement. From position to the displacement we will go. Okay, what do you mean by displacement? Okay, displacement. Okay, it can be defined in various ways. What is meant by displacement? It can be explained in various ways. First, let us start with the basic definition. What is the basic definition? It is the change in position of a particle. It is the change in position of a particle with respect to origin. With respect to origin, if a change in the position occurs in space, that is called displacement. Okay, So how, suppose the particle was at 4, now it comes to 6, it comes to 6, okay. We will call this position as x1 as it is on the x-axis. We will call this position as x2 as it is in the x-axis itself. Then what is displacement? Displacement delta x is equal to, displacement delta x, delta means what? Change, delta means change in position is equal to x2 minus x1. What is x2 here? 6 minus x1 is 4, that is equal to 2. Delta x is equal to 2 meters. This is our displacement because x2 is plus 6. See, in this real number line, we should follow one particular convention. What do you mean by convention? The word convention. Convention means, you know, Kannada? Sampradaya anta heli. Convention means sampradaya. We have a sampradaya here. What is that sampradaya? Whatever comes out to be the right side of origin is always taken to be positive. Whatever comes out in the negative, left side of the origin is to be taken negative. Whatever comes to the upper side of the origin is positive. Whatever comes to the downside of the origin is negative, okay. Upper positive, right positive, left negative, down negative. This is our convention. ಇದು ನಾವು ಮಾಡಿಕೊಂಡಿರೋ ಸಂಪ್ರದಾಯ. ಹೇಗೆ ಸಂಪ್ರದಾಯ? ಈಗ ದೊಡ್ಡ ಮಗನೇ ಮನೆ ಯಜಮಾನ ಆಗಬೇಕು, ಬಲಗೈಲೇ ಊಟ ಮಾಡಬೇಕು ಅಲ್ವಾ, ಮನೆಗೆ ಬಂದ ಕೂಡಲೇ ಕೈಕಾಲು ತೊಳ್ಕೋಬೇಕು, ಹೀಗೆ ಸಾಯಂಕಾಲ ದೀಪ ಹಚ್ಚಬೇಕು, ಇದೆಲ್ಲ ಒಂದು ಸಂಪ್ರದಾಯ ಅಲ್ವಾ. ಇದಕ್ಕೇನಾದ್ರು ಸೈಂಟಿಫಿಕ್ ಬೇಸಿಸ್ ಇದೆಯಾ? ಇದೆಯೋ ಇಲ್ಲೋ ಗೊತ್ತಿಲ್ಲ, ಬಟ್ ನಮ್ಮ ಅನುಕೂಲಕ್ಕೆ ಮಾಡ್ಕೊಂಡಿರೋದು ಇದೆಲ್ಲ ಒಳ್ಳೆಯದಾಗಲಿ ಅಂತ. ಇದು ಕೂಡ ಅಷ್ಟೇ. ದಿಸ್ ಈಸ್ ಫಾರ್ ಅವರ್ ಕನ್ವೀನಿಯನ್ಸ್ ಓನ್ಲಿ. ವಾಟ್ ಈಸ್ ದ ಸೈಂಟಿಫಿಕ್ ಬೇಸಿಸ್ ದಟ್ ವಾಟ್ ಎವರ್ ಕಮ್ಸ್ ಟು ರೈಟ್ ಈಸ್ ಪಾಸಿಟಿವ್, ವಾಟ್ ಎವರ್ ಗೋಸ್ ಟು ನೆಗೆಟಿವ್, left is negative? No, there is no scientific basis for this. It is just simple our assumption. It is for our convenience we have made these rules, okay. This is a convention. This is called right hand athwa Cartesian convention. We call it as Cartesian convention, Cartesian coordinate system, okay. We are following Cartesian coordinate system. This is called Cartesian convention, okay. Yes, okay, leave it. So here left, right side x2, that is 6 meters, right side x1 4 meters, 6 minus 4, that is 2 meters is the displacement, okay, fine. Now displacement will not stop here. The concept of displacement will not stop here, it will grow further. What is that? Suppose from 6 meters, from 4 meters you have gone to 6 meters, from 6 meters you will come to 2 meters again, suppose. Then the first position is x1 because your journey started from 6 meters, right? Your journey started from 6 meters, that's why your initial position is x1. Now your journey ended at 2 meters, so this is your x2. Got it? Because you are coming backwards. Coming backwards means you are coming to the left side of the origin, means your motion is negative. All your numbers will take negative form. That's why delta x is equal to x2 is plus 2 minus x1 is plus 6, so it becomes minus 4 meters. So this is your displacement, means you have moved 1 2 3 4 units to the left side. That's what this number is telling you. You moved to the left 4 units. Earlier you moved to the right 2 units. Okay, it is not only telling you how much distance you covered, it is also telling you how do you go, what is your direction. So that is why displacement is a specific quantity which not only tells you what is the value, but it will also tell you direction. It has got value, it has got a direction. That is why displacement is a vector quantity. What is vector quantity? Maybe in high schools you might have heard something like this. The quantities which have magnitude and direction are called vector quantities. The quantities which have only magnitude, not the direction, they are called scalars. So there are two quantities, scalars and vectors, and here displacement is a vector quantity, because it not only tells you how much you are moving, but it will also tell you where are you going. Okay, yes, that's why displacement is a vector quantity. Okay, suppose we will start from okay 3 meters. We will start from 3 meters. We will go to 6 meters. What is your displacement? x2 minus x1. So now x2 is 6, x1 is 3. Okay, yeah, x2 minus x1 is 6 minus 3, that is 6 minus 3 is 3. So total displacement is 3 meters to the right side. Suppose after coming to 6, you will come back to 3 again. So displacement we will calculate like this. Total displacement is 6 minus 3 in the beginning. 6 minus 3 in the beginning. Later what happened? Later you started coming to the left side, right? Later you started coming to the left side. So 6 minus 3 plus, there are two displacements here. One is the displacement to the right side, another one is the displacement to the left side. Now from the left side you started with x1 6 and ended with x2. Here x2 minus x1 is to be written. What is x2 and x1 here? 6 minus 3 plus, what is x2? 3 minus, yes, x2 minus x1, 6, x1 was 6. Now what will happen? 6 minus 3 is 3 plus 3 minus 6 is minus 3, that is equal to 0. Your total displacement will be 0. It means what? So you have made certain displacement and you came back to the same initial point, then your total displacement is 0. Okay, yes. Okay, yes. There comes out to be another very subtle point here. See, you have your house is at A, your market is at B. Okay, H is the house, M is the market. From house to market there is 5 kilometers distance. You will go from house to the market and you will see that the market is closed today because of corona. So what you will do? You will come back to your house. So you have a cycle. Suppose you don't have a cycle also. You have to walk 5 kilometers. You have walked 5 kilometers from your house to the market. You are tired. And since the shops are closed, you will come back to the house walking additional 5 kilometers. Okay. If a scientist will ask, if I ask a scientist, a mechanics student, what is the total displacement of the boy from going from H to M and M to H? He will say H to M 5 kilometers, 5, and M to H minus 5 because it takes left side journey. So the total displacement is 0, he will say. Okay. But if I ask you, whoever has walked the miles, so then what you will say? I have walked 10 kilometers, you will say. Why? Because you have walked 5 kilometers to the market and you came back from the market to the house again 5 kilometers. Then what you will say? I didn't walk at all. I didn't even move an inch. I was there only. Would you like to say like that? Never. You will always say, see, I have walked 10 kilometers. That's what you say. So what you have counted is not the displacement. What you have counted is the path length. You have calculated the path length. The path length you have calculated. 5 plus 5. It is not equal to 0. It is 10. Okay. It is not equal to 0, which is equal to 10. So it is 5 plus 5. Why it becomes 5 plus 5 for you? Because you don't consider displacement as the vector quantity. You are not considering the right side and left side motion of the particle. You are just only considering the magnitudes. How much distance I have moved, whether it is to the left or right or back to the left or whatever it is. You are not considering how do you move. You are only considering how much I moved. You have moved only a path length, which is called distance. You have moved a distance travelled. It is not a displacement. In mechanics we call it as distance. Distance is different from displacement. Distance is also known as path length also. Distance and path lengths are almost same, similar in meaning, okay. Whereas displacement is very specifically defined, which is the position, change in position of a particle with respect to a coordinate, okay. This is one definition. After looking to this, we will define distance and displacement even more elaborately, okay. Yes. So by this we saw that one thing is very clear: displacement can be 0. Displacement can be 0, but distance cannot be 0. Need not be 0 always, because if you go 5 kilometers and come back to 5 kilometers, displacement can be 0, but distance is 10 kilometers. They are different here. Both are different here. Suppose you go to house, you leave the house, you will go to the market and you stayed there. Suppose that market wala is your friend. You are talking with him for 1 hour. Then what is the displacement made by you? Displacement made by you is 5 kilometers. We will neglect your backward journey. We will take only your forward journey into consideration. What is your displacement? 5 kilometers. What is the distance travelled? That is also 5 kilometers. Got the idea? Distance is also 5 kilometers. Displacement is also 5 kilometers. No difference here. But if you take this backward journey also, displacement is 0. Distance is 10 kilometers. So distance and displacement can be different in different perspectives. They need not be same every time. They can be same only in certain aspects, okay. Since we are considering motion in a straight line, we are sticking our motion only to the straight line motion, not to any other motion, okay, right. We will make displacement definition even more clear by considering this example. Suppose there is a point called A, there is a point called B. There are two towns. Let's take Chitradurga and Davangere, separated by a distance of 60 kilometers. Okay. So one way of going from Chitradurga to Davangere is the straight line motion, which only can be taken using an aeroplane, okay. Because the roads between Chitradurga and Davangere are not straight. They will be curved. They are having turns and curvatures, okay. Is it the only way to go from Chitradurga to Davangere? There are hundreds of ways, thousands of ways, crores of ways to go from Chitradurga to Davangere. One standard distance is 60 km, which is the straight line path between C and D. If I take another path which is taking 65 kilometers, is it not another path of going from C to D? Is it not possible to go from C to D like this? Yes, it is very much possible, but the distance is not equal to 60 kilometers. I will take another path which is almost close to this. It will be 61 kilometers, but will never be 60 kilometers. I will take another curved path which is nothing but 70 kilometers, maybe a more curved path going across the villages. Then it may be 70 kilometers or 60, okay, 70, let's take 70 kilometers, which is not equal to 60 kilometers. There may be hundreds of paths like this. Numerous paths can be made, but nothing will match to this particular CD, which is the straight line path, which is the shortest path between 2 points. So what is displacement actually? Displacement is actually the shortest distance between 2 points. Remember this very well. Displacement is the shortest distance between 2 points in space, okay. So that is why displacement, see, this is a point 2, this is a point 4. What is the displacement? Bring the shortest distance between them. What is that? Straight line path. Straight line is the shortest distance between 2 points in this earth surface, in the space we live. In the space we are living here, we are living on a flat surface. We think like that because the whole world appears to be flat for us, even though it is not. We are living in a flat world, Euclidean world, in more scientifically if you would like to put it, we are living in Euclidean space. Euclidean space. Since we are living in Euclidean space, everything appears to be flat, and the shortest distance between 2 points is always the straight line path, like this. Always the straight line path. A curved path cannot be a shortest distance between 2 points. That's why displacement means another definition follows. What is that? Displacement is the shortest distance between 2 points in space. Let me write this. It is the shortest distance between 2 points in space. It is the shortest distance between 2 points in the space. Okay, this is the definition of displacement. Got the idea? Displacement is different, distance is different. Okay. Yes.